So for today, we're going to be talking about your quadratics or quadratic graphs. Today will just be an overview of the whole topic and everything you'll need to learn. So it won't include certain things in detail. So let's start off with the form of your quadratics. Generally speaking, they will give it to you as ax squared plus bx plus c in the exams. The only thing this particular form tells you is pretty much how the graph is shaped. So if in this case, so you have two scenarios, this particular shape is called a parabola. And if you're given a scenario where the a value here is bigger than 0, then the parabola will have a shape like this. The way I remember it, it looks like it's smiling. Okay. Whereas if the a value is smaller than 0, then the parabola is like sad. So just remember that. Then if we have a look at what they can ask you, they could give you different forms. So for example, the first one, it looks like this: a bracket x minus p bracket x minus q. Okay. In this particular form, if you see that, a lot of the time they tend to be asking you either to factorize it to get this form, or solve it to get the roots, or they're going to ask you to expand it. If they ask you to solve for it, then that's just asking for finding the roots. And what that means is that if I had the parabola, so I'm just going to assume that it's always going to be smiling now, just because I want to keep this short and simple. If they give you this form and they ask you to solve it, then they're asking for the roots, in which case the two parts in which the parabola will cross the x-axis, they are actually values p and q. Notice how here it's minus p and here it's minus q, but on the parabola itself, they're actually plus p and plus q. The other form that they will give you is completing the square. You have your a bracket x minus h whole bracket squared plus q. For something like this, they call this situation a completing the square situation. Let's just call it complete the square. And for a situation like this, the thing that it tells you is the vertex. The vertex can either be the maximum point or minimum point. And sometimes even rather than calling it the vertex, they call it the turning point. Either way works. But having said that, the coordinates of the vertex is going to always be h, k. This, again, notice here, this is minus h, whereas this is plus k. Here, however, is h and k, so where both are positive. So only the h has been reversed in this sign. If I have a curve again, this part here will be the vertex. And let's have a look at an example. Let's say I have x squared minus 5x plus 6. Let's say they'll ask you to factorize this. If I factorize it, there's many methods. However, I won't go through them today. So let's just say, for the sake of it, we want to factorize it. When I factorize it, this gives me x minus 3 and x minus 2. Then, if I had to solve for this in order for me to get the roots, so it would look like x squared minus 5x plus 6 equals to 0. And then from my previous part, I know that this is x minus 3 and x minus 2. And that's also equal to 0. And then I can technically separate the two brackets, x minus 3 equals to 0, or x minus 2 equals to 0. Then that leads to solving it algebraically, which then means x is equal to 3 or x is equal to 2. So this is part 1. So if I were to draw the graph on the right side, this is my x-axis. Because the value before the x squared is technically a 1, so this is why we don't write it, because it's just positive 1, then I know it is smiling. And on top of that, now thanks to what we did just now, I know that the points at which the graph will intercept the x-axis will be at 2 or 3. And then from the fact that if we look at the original graph itself, probably we can say that if x is 0, 0, because anything with on the y-axis is always going to have an x-coordinate of 0. So to find out what the y-intercept is, this is just like 0 squared minus 5 times 0 plus 6. And if we solve for that, that's actually equal to positive 6. So I know that this is going to be 6. We can take it further now and find the vertex by completing the square. So I'll take again the original equation, and that will be x squared minus 5x plus 6 and equal that to 0, but this time I need to complete the square for it. So to complete the square for it, then the first thing I need to focus on is this part, the first 2 bits, and I know that that is going to be x minus half of that, so that will be 2.5 whole bracket squared, and then because I did that, I have to do the same thing outside, minus 2.5 squared plus 6 equals to 0. And then from there, I need to tidy up this half of it. That will be negative 0.25. Based on what we said earlier, the vertex is equal to the h value, which is inside the bracket, and again the 1h, it's going to switch sides here, it's negative, therefore it's actually going to be a positive value, but the k value, or the y coordinate, which is this one, it's going to remain unchanged, so it's negative 0.25. So going back to the diagram we just had, that means that the vertex here, or in this case the minimum turning point, will be 2.5 and negative 0.25. Okay, so that is the big summary of what you guys will need to know for quadratics. I hope you guys found this useful. If you have any comments, questions, or concerns, please leave it in the comment section below, and I'll see what I can do. Bye-bye.